Welcome everybody, this is 5.5. We are doing the second part of solving rational equations. So our last lesson we focused more on linear solutions. So you end up getting one solution when you're done. Today we'll be talking about quadratics. So right here, there's just a quick starter. If you'd like, maybe pause and give these a try. We'll see it some more as we go along, but just to keep this video a little shorter, I probably won't go over that here, okay? So when we're solving rational equations, again, first off, we need to make sure that we factor the denominators. That will help us to get a common denominator for every term, okay? Once we factor, we then multiply any term to get a common denominator. So we'll do an example of that in just a minute. And then after we get that common denominator, we're able to multiply both sides by that common denominator to clear out your denominator entirely. So then we just have the numerators that we can use to solve, okay? So we'll talk a little bit about that too. So here we go. Here is a problem where we need to get our solutions. First, we will factor the denominators if possible. So if you look here, this is the difference of squares. So I'm going to zoom in a little bit. That will give us our two factors. We'll have x plus 3 and x minus 3. So again, if you ever see the difference of two numbers that can be written as something squared, like 9 is the same as 3 squared, then that will give us our factors, okay? So here we've got an x plus 3, we've got an x plus 3, but this term does not have an x plus 3. So we will multiply top and bottom by x plus 3. We'll do the same with our x minus 3. We have another x minus 3, but in this term, we don't have an x minus 3. Okay? So now we do have a common denominator. Every term has the same denominator, which means, again, we can multiply both sides by that common denominator. Again, like when we are, if we have an equation, we can do whatever we want as long as we do it to both sides. So we can multiply both sides by that denominator, and that will cancel or clear all of those denominators, okay? So all that's left is that's what we're going to use to solve, okay? And it's just kind of like when we were graphing before, and I asked you to write down the x-intercepts. Those are your solutions, and those always came from the numerators, right? The factors on the top, all right? So here we go. We'll have x times x is x squared. X times 3 is 3x. X times x is x squared. X times negative 3 would be negative 3x. And then that is equal to 2. So combine like terms, that's always a good thing to do if we can. So this will give us 2x squared. These two terms will cancel, and that's just equal to 2. So one of the things that we can do to solve is if we have a single term with an x, then we can just solve for x using order of operations. So it's like PEMDAS, but backwards. So the first thing that we would run into would be this 2 times x squared. So we need to get rid of that by dividing both sides by 2. And then we would then get rid of our exponent by square rooting both sides. But just don't forget that we'll have a plus and a minus, right? Why? So if you kind of remember, if we were to plug 1 in here, that would satisfy the equation. 1 squared is 1. If we plugged in a negative 1, that would also give us a positive 1. So that's why we end up having, or at least one of the reasons why you could say it is because of that. That's why we have the plus or minus, okay? So those are our two solutions, okay? So that would go right here. Excluded values, again, is what would make the bottom 0. at any time. So really, we just really need to look at it here from the original ones. We're not doing any like once we have a common denominator, we're good. So we have a -3 and a +3 would be our excluded values. And then again, last time we talked about, maybe I'll write this here, so 1 and -1. Extraneous solutions are our solutions that end up being the same as an excluded value. So it can't be both. So for this case, we don't have an extraneous solution because our solutions are not excluded values. So we'll just say D and E. Okay? All right, so let's just try a couple more. Same thing, we need to have a common denominator. So here we have an x. This doesn't have an x, so we'll need to multiply. And this doesn't have an x either, so we'll multiply top and bottom by x. So now every term has an x. We need to do the same with this 9. We'll multiply top and bottom by 9. And now we have a common denominator. So we could multiply both sides by 9x, and that would clear out the denominator. And so we'll have 9 minus x squared equals 0. You could do the same sort of thing. We could get the x on one side. So here I'm just going to add x squared to make it be positive. So 9 equals x squared. And then we could get rid of the exponent by square rooting. But just don't forget your plus or minus. So we'll have x equals 3 and -3. Again, there's more than one way to do these types of problems. Like this is the difference of squares, what I'm just circling. So you could use difference of squares, you could factor. But here's just two examples where you could just solve using order of operations. Okay, so solutions here would be 3 and -3. Excluded values for this example is 0. So just a reminder that if you ever have an x that's not in like a parenthesis with another number like x minus, or we'll say +9, like this would give us a solution of -9. But when we have something like 9x, what would make this 0 is x would have to be 0, right? Because 0 times 9 would give us 0. For like this example, if we did -9 minus 9, or sorry, +9, that would give us 0. So kind of think about the two different situations here, okay? An x by itself that's not in a parenthesis will always result in a 0, or an x being 0 would make the whole thing be 0, okay? So this also does not have an extraneous solution. All right, we're going to skip C and D. Kind of thought about that for time. If you want more practice, give it a go. But I think we'll be good with these last 4 examples. All right, so again, common denominator, or I guess first check for factoring. There's no factoring in the denominator. Again, we don't really care about the tops. We actually want the top not to be factored so that we can maybe potentially combine like terms. Okay, but on the bottom, looks like we already have a common denominator. So we could multiply both sides by x plus 5 and it would just cancel out those, right? So like we could do x plus 5 and x plus 5, and those would just all just cancel. Okay, so here we'll have x squared plus 9x equals -20. So watch out for that. Sometimes we have negatives that are out in the front of your fraction, and that still is part of your equation. And then we could add 20. Make sure you add it to like terms. So there's no like terms with that 20, so it's just going to be a plus 20. We'll factor. So what multiplies to 20 and adds to 9 would be x and plus 4 and x plus 5. Right? Again, if you feel like the puzzle, like doing the two things that multiply and add, if that is helpful for you, then keep doing that, okay? So our solutions, what would make those factors be 0 would be -4 and a -5. So those are our two solutions. So let's write those down. So -4 and -5. Excluded values. So what makes the bottom 0? So if we come back to here, what would make that 0 would be -5. So if you remember last time in class, we talked about this, but just in case you weren't here, excluded values are solutions that cannot work. And if your solution is the same as an excluded value, then that means that that is not actually a solution. It is called an extraneous solution, okay? So we would get rid of one of our solutions and write it as an extraneous solution. All right, let's try another example. If you would like, give this a try, pause it, and see what you got, okay? So it's always helpful to make everything be a fraction. It's hard to know what the common denominator is if it's not already factored. So here we could factor this, what multiplies to 35 and adds to 12. Looks like that would maybe be 7 and 5. So 7 times 5 is 35, and 7 plus 5 is 12. And then we need to have a common denominator. This one's maybe a little harder than what I remembered, but we're going to give it a go anyways. So we've got an x plus 5 and an x plus 5, but this does not have an x plus 5. This has an x plus 7. I'll do a purple for that, but neither of the other terms have an x plus 7. And we'll need to do that. I'm going to try and squish that in here. Okay, so now all of the denominators are the same. So we could multiply tops and bottom, or tops, both sides by that, and it would cancel them all out, okay? And then what we've done in the past is we always distribute what's on top. So we've got this, we already know what that is when you distribute, because we just factored it out. So this is just x squared plus 12x plus 35, right? That's coming from distributing that, okay? Which is what we had over here. All right, if you want to use a box and go back to this, that would give you the same answer. And then we're going to add x plus 7 equals 2. All right. So combine like terms. We only have one term with x squareds. We have 2 with x's, so that would give us 13x. And then we can combine these to give us 42 equals 2. And then maybe subtract that 2 back to the other side. So that will give us give us a 40. All right, that was a beast, but you got it. Okay, and then we need to factor what multiplies to 40 and adds to 13. So that would give us x plus 8 and x plus 5. Because 8 times 5 is 40, and 8 plus 5 is 13. All right, so then our solutions would be -8 and -5. So let's write those down. Okay, word of advice, before you push enter on your, on the online homework, write down your excluded values, because again, it might tell you that something's wrong because one of those numbers might be an excluded value. So let's look and see. So x cannot be -7 or -5. So again, that just comes from our factors. What would make those 0? So if you look at that, it looks like x minus 5 is not a solution. It is an extraneous solution. Okay, so hopefully that's kind of making sense. Again, if you're having a hard time, finish the video, give it a go, and then come and get some help if you need. Okay, all right, here's our last two examples. Need a common denominator. This has an x plus 6, but this side does not have an x plus 6. This has an x, but this side does not have an x. So now we have a common denominator. Cancel those out. We'll have x squared plus 9x equals 4x plus 24. And then we need to have everything on one side, right? This is a quadratic. We have more than one term with x's, so everything needs to be on one side. So we'll subtract 4x, and we'll subtract 24. So x squared plus 5x minus 24 equals 0. And then we just need to figure out what multiplies to negative 24 and adds to 5. Okay, so perhaps, I probably need a little bit more space for that. We could try negative 8 and a positive 3. That should work. Okay, so our solutions are 8 and negative 3. Try that one more time. It's a little better. Okay, so we'll write that down, 8 and negative 3. And again, your homework may or may not have this part written out. I'd encourage you to at least abbreviate, just so you know what is what. Okay, all right, excluded values. It looks like x cannot be 0 or negative 6. So 0 and negative 6. All right. And then do we have any extraneous solutions? I don't think so, right? None of those match, and so we would have D and E. All right, let's do one more example. This has an x plus 1, but this does not. And this one does. Okay, so we're good with our x plus 1s. We've got an x, but this does not. So don't need to print this either. And neither does this. I'm just going to put my other x over here. All right, so now we have a common denominator. Again, here is a common mistake. Here is there's this negative, and that kind of goes with that 2. Okay. Also, another thing is we have a negative 4 here. When we distribute, that negative should go with it. Okay, so here we've got x squared, and then we'll have negative 4x minus 4 equals negative 2x squared. All right, get everything on one side, so we do need to add 2x squared to both sides. So that'll give us 3x squared minus 4x minus 4 equals 0. So it's probably been a while since you've seen this, but a isn't 1, so the leading term isn't 1, it's 3. So for this example, we need to factor using a box, okay, or factor by grouping. So we need to still know what multiplies to negative 12 and adds to 4. So here I'm just going to write down my little puzzle. So multiplies to negative 12 and adds to negative 4. So that would give us 6 and 4. So like negative 6 and a positive 4. And then again, we can't come up with our factors quite yet because a is not 1. So again, the first term goes in the first box, the last goes in the last, and then our other 2 is our puzzle, right? We broke that middle term into 2 parts. Sorry, I think I made a mistake here. Those are supposed to be 2's. There we go. Okay, so then we'll do GCF of each row and column. Double check, make sure it multiplies incorrectly. Looks good. So we'll have x minus 2 and 3x plus 2 equals 0. So what would make those 0? Well, if x was 2, that would make the first factor 0, and the other would be negative 2/3. Okay, so again, you can do that by subtracting both sides by 2, and then we could divide both sides by 3. Okay, so those are our two solutions. Let's see if we have any excluded values. So let me just write those other ones down really quick. Excluded values, x can't be 0 or a negative 1. And so there's no matching. None of the excluded values are our solutions, so we'll have another D and E. All right, so that kind of finishes that up. We'll have one more lesson after this where we'll do applications, and then we'll have our review and test. Okay, we'll see you later.